Hello everyone. So this is the 3 number question from our practice quiz. So about the red and blue graph. Use the red and blue graphs below to answer the question. The scales of the graph are not given, so multiple functions are possible. Possible multiple functions could possibly produce each graph. However, each of the questions below has only one correct answer. So this is the first question. From this first question, first by looking at the question, what do you understand? You have to think about this. What is this graph look like? What this graph is looking like? Is it some kind of uh, what is possible here? Is it exponential graph? Is it logarithmic graph? Think about this little bit. Or is it a straight line? What is this? Is it a straight line? Is it a parabola? So that you have some sense. Okay, you can converse your idea concept. Then as options are given, which is another good way to direct your thinking to some correct order. Okay, so we have to look at the options also. First question is about the rate graph. Which function could produce the rate graph? Now you see this rate graph, and it looks like some 2 to the power x, 1 by 2 to the power x. This kind of thing is talking about in the option, which means which means we have uh, some exponential kind of thing, and actually this is exponential function. This is exponential function, and as you can see, there is no value given here. So we do not exactly know that what is the value here. Is it 1 comma 0? Is it 2 comma 0? But for sure we know that this graph is not near to the x line. That means the graph moved some unit up. The graph moved some unit up. What is that some unit? We do not know because the value is not given. But we know that the graph moved some unit up. That's for sure. That is what we know. And this graph, as you can see, actually in this graph, this is 2 to the power x plus 1, and this is 1 by 2 to the power x plus 1. So these two option is the candidate for this rate graph, because here it is plus 1, here it is plus 1. So the graph moved some unit, maybe plus 1 unit it moved up. Now see, so which one is correct? Is it 1 by 2 to the power x or 2 to the power x? The reason why it is this one is correct, the reason is actually this is the positive 2 to the power x graph. Positive 2 to the power x graph. So the reason is so I think I should take this drawing something. Okay. Look, this is actually 2 to the power x graph. Somewhat 2 to the power x graph moved some unit up. This is 2 to the power x graph. So you can say, sir, how do I know that this is 2 to the power x? Why not 1 by 2 to the power x? Suppose this 1 by 2 to the power x plus 1, that one. 1 by 2 to the power x plus 1 or 2 to the power minus x. 1 by 2 to the power x. Actually, 1 by 2 to the power x graph is this one. 1 by 2 to the power x graph is the opposite of this graph, which is this. Okay, so 1 by 2 to the power x graph. So that's why 1 by 2 to the power x, this graph, this is impossible. They are not answered. Do you understand? They are not answered. The reason is this, because this 1 by 2 to the power x graph is just opposite. There will be some y-axis reflection for 1 by 2 to the power x. If you give a minus here, 1 by 2 means what? 1 by 2 means what? 1 by 2 means 2 to the power minus x. They are same thing. 1 by 2 to the power x means they are where it is hiding. So yeah, so 1 by 2 to the power x means actually 2 to the power minus x. 2 to the power minus x graph means like this. Okay, 2 to the power minus x graph means like this. So basically, that's why other candidates are not possible. Other candidates are not possible. That is the reason. That is the reason. That is the reason. Okay, so that's a 1 by 2 impossible, 1 by 2 impossible, because this is not the 1 by 2 graph. And 2 to the power x, why it is not correct? Because the graph actually moved some unit up. If it is 2 to the power x, then this line has to come closer to the x line. Then it will be 2 to the power x, 1 by 2 to the power x graph. Now again I have to say, like I have to say this is 2 to the power x plus 1. Then how do I know that this is plus 1? 1 unit up, move 1 unit, it moved up. How do I know? I do not know. I'm just saying maybe it moved 1 unit up. Maybe if it is, if suppose if the question is given like, if the question is given like, let's say if the question is given, this option is given like fx equals to, fx equals to, suppose fx equals to, it is given 2 to the power x, suppose 2 to the power x plus, suppose plus 4 is given. What can I do? Actually, that is, this is also correct for this graph. This is also possible. Maybe this is the graph. I do not know. But we know that some unit it moved up, and this some unit means what, we do not know, because this value's coordinate, the coordinate of this value is not given. That's why we do not know. But we know for sure. We know that this is some positive graph. Okay, let me show another one so that you understand what I mean. Suppose if I give you here 6 to the power x plus 15. Suppose 6 to the power x plus 15. This is also possible. Maybe this is the graph, this one, and this is also correct. Okay, if I write this is also correct. Maybe it is 6 to the power x plus 15. Maybe 15 unit it moved up from its 6 to, from the 6 to the power x graph. Okay, this is also possible because the coordinate of the graph is not given. So, but we know that some unit it moved up. So some number can come here, no problem. Any number can come here, no problem. And it has to be like 2 to the power x. It has to be like 3 to the power x. 3 to the power x also possible. 4 to the power x, 5 to the power x, something to the power x, because of the shape of the graph. Because of the shape of the graph. So it has to be something to the power x. Okay, minus x, not possible. Minus something to the power x, not possible. Do you understand? Positive, something to the power x, then plus something, because of the shape of the graph. Actually, we understand this. So suppose you can say, sir, how do you know that this? Actually, this is possible, and others are also possible. Others are also possible. Suppose this is also possible. This is also possible. All of them are possible. Do you understand? All of them are possible. So this is what I mean by this. Actually, all of the graphs are correct for this one. Possible because the scale is not given. Just we know the shape and it moved some unit up. Just we know that. So let's go to the next one. I should clear it first. Clear my drawing. Okay. Actually, I can discuss that one also. Which of the following graph could produce the blue graph? Now, this is ln minus ln x plus 1. This kind of thing is the correct answer. As you can see, actually, this is correct. But why it is correct? Why others are not correct? This blue graph, this graph, like how it is correct and how others graph is not correct. The reason is actually similar to this analysis, but only difference is this is e to the power something to the power x graph. This is actually negative ln x graph. This is actually negative ln x graph. So let me take the red color. Negative ln x graph. So this is actually negative ln x. Negative ln x graph moved 1 unit to the right. Negative ln x graph is like this. And negative normal ln x graph is like this. Let me write normal ln x graph also if you are interested. Normal ln x graph is like this. Normal ln x graph is like this, and then negative ln x graph is this. Negative ln x graph is just a reflection of this graph to the x-axis. So there will be some reflection for this graph to the x-axis, which will be somewhat like this. This is the minus ln x graph, and you can see the shape is similar. This graph is this. That's why it is minus ln x graph. Now you see the point is not here. The point is not here. The point is not. The point is not. The point is not there. The point is not here. The point is higher now. Point is in the 0. That means it moved higher, left or right. It moved to the left. And when it moved to the left? When it is plus 1. For the plus 1 horizontal axis and bracket also. bracket plus 1, then it moved to the 1 unit to the left side, then it moved 1 unit to the left side. Okay, and you can say, sir, how do you know that it moved 1 unit? Trust me, I do not know. I'm just saying from the example, from the given option. Suppose, what I mean by I do not know. What I mean by that is, the reason is, suppose if the option is given ln x plus 5, this is also correct. This is maybe because the scale is not given. Do you understand? The value is not given. What is here? Is it 1 or 5? I do not know. What is given here? It is 5 or 10. I do not know. We do not know. You also do not know, because there is no value given. But we know that the shape is what? The shape is minus ln x. This graph is minus ln x, and it moved some unit to the left. So maybe that some number is 1. Maybe that some number is 5. Do you understand what I am trying to mean? This number can change. This number can be anything. Eh, but it has to be x plus something, because it moved to the left. For moving to the left, just to move to the left, it has to be plus something, x plus something, for moving to the left and within the bracket. Do you understand? So that's the point. Actually, that's the point. And you will see our other options for this question actually like this. Which of the following graph could produce the blue line? And here we said answer is minus log x plus 6. This is also correct. Log they produce the similar graph, not same, similar graph. They produce the similar shape is similar. The shape will be similar. See, that minus again came here, that minus, and it is x plus 6. I said plus 5 possible, plus 6 also possible, plus 7 also possible. Now you can say, sir, it is log, but that one was ln, which is, you see that ln is a special kind of log, you know, right? Log and ln is a special version of one another. Basically, if the base change, if the base of log is e, then it becomes ln, but the shape of the graph will remain same. The value will be little bit changing, you know, like maybe the one graph was like this, another graph is like this. Yeah, but the both shape will be same. Suppose one graph or shape is like this, the other graph will be shaped like this. Little bit, they will little bit change, but main pattern will not be different. That's the point. So this number can be little bit different. And I skipped 3 number. I think you noticed it. This is actually, as I said, for the exponential, that red color. As I said, this number can change. So 2 to the power x plus 7, it can come. Now I think you know that, because this number can change. But what cannot change is this. There cannot be any minus for the x. All of a sudden minus cannot come for the 4. This 4 and 7 can be any number. Why it can be any number? Because the scale in the graph, the main graph, scale is not given. That's why they can be different numbers. Some people can come and say, okay, maybe 7 unit it moved up, maybe 10 unit it moved up. Some people can say different argument. People can come with different argument, and we have to accept it because the scale is not given. But nobody cannot say all of a sudden it will be minus 1 by 4 to the power x. This is not possible, because then the graph shapes changes. And then the graph will have some flip, this way direction flip, x-axis reflection, y-axis reflection. Then the graph will have all this reflection for different positive, negative. If you are interested, let me show you quickly a few. You let me show you quickly for if you are interested. Why? Suppose 4 to the power x, 4 to the power x graph is 4 to the power x graph is. Okay, I will show all of them together. Then 4 to the power minus x graph is which one? I will draw another color. That's why I am not showing it. Then let's say minus 4 to the power x graph is which one? Minus 4 to the power x graph is which one? Then minus 4 to the power minus x. This is for advanced analysis. I mean, if you are interested. So this is what happens actually. Let me take another color. You can plot all the value and find out the answers, but I'm just showing. I'm drawing the graph freehand. 4 to the power x graph is this one. And this graph is like this, because y-axis reflection, because of this minus, and because of this minus before the function is x-axis reflection. So the graph will, this graph will now come down to here. Okay, then this graph, there will be another reflection here, there will be another reflection there, this graph. So do you understand? So see, this is what I meant. If I give all of a sudden minus, then their shape will change. And I think you already noticed our main graph is this shape. Okay, our main graph is this shape. The graph that has been given there. Let me erase it and let me show you. See, what is the shape of this graph? This one, right? This one. See which one is matching? This one is matching. With all of them, they are not matching. Okay, these are not matching. Which one? This one is matching. That means it will be 4 to the power x, 2 to the power x, something then plus 1. This is what I meant by that. Okay, this is what I meant by this. So basically, our main shape of the graph will remain same, and other things will interchange. Other thing will come to adjust and address all this uplifting. Just the point moved some unit up. This is what I mean by this. So yep, that's the answer. So I think now you saw the answers. Red graph, maybe red graph is this one. Uh, maybe blue graph is minus ln x plus 1, or maybe log minus log x plus something. Then this is the correct answer. Then this is the correct answer. I think now you know the reason. The reason also. All right.